Have you ever truly looked at a diamond? Not just glanced, but really it? Held it up to the light and watched the dance of fire within? It's more than just a pretty stone. It's a testament to the power of order, a tiny, glittering universe of perfectly arranged atoms. For millennia, diamonds have captivated us with their brilliance, their rarity, and their enduring beauty. They adorn crowns, symbolize eternal love, and are coveted as investments. But beyond their monetary value and cultural significance, diamonds hold a deeper secret, a fundamental truth about the nature of reality itself. They are a window into the world of crystals, a world governed by the precise and unwavering laws of geometry. Each facet, each angle, each perfectly formed edge is a reflection of the underlying atomic structure, a structure so stable and so strong that it can withstand immense pressure and endure for billions of years. Think about the journey of a diamond, forged in the Earth's fiery depths, brought to the surface through volcanic eruptions, and then meticulously cut and polished to reveal its inner radiance. It's a journey of transformation, a testament to the enduring power of nature's artistry. And it all begins with the simple yet profound arrangement of atoms in a repeating pattern. Or just a simple grain of salt. Something so common, so readily available that we often take it for granted. We sprinkle it on our food, use it to preserve meats, and even dissolve it in water to gargle away a sore throat. But have you ever stopped to consider the microscopic world hidden within that tiny crystal? Have you ever marveled at the sharp, geometric edges, the perfect cubic shape that defines its very essence? Salt, like diamonds, is a crystal, a testament to the inherent order that exists within the seemingly chaotic universe. It's a reminder that even the most mundane objects can hold extraordinary beauty and complexity, if only we take the time to look. Each grain of salt is a miniature work of art, a testament to the power of self-assembly, a process by which atoms spontaneously arrange themselves into highly ordered structures. And this process, this fundamental drive towards order, is not unique to diamonds and salt. It's a universal principle that governs the formation of everything from snowflakes to galaxies. So, the next time you reach for the salt shaker, take a moment to appreciate the hidden beauty within. The perfectly ordered arrangement of atoms that makes it a crystal, a tiny window into the fundamental laws of nature. You are looking at a crystal. Its atoms are arranged in a perfectly repeating pattern, a three-dimensional grid that extends throughout the entire structure. They repeat in space, creating a beautiful, stable structure, a testament to the power of order and symmetry. This repeating pattern, known as a crystal lattice, is the key to understanding the unique properties of crystals. It's what gives them their strength, their hardness, their ability to refract light in such dazzling ways. Imagine a perfectly organized army of soldiers, each standing in precise formation, shoulder to shoulder, row upon row. That's essentially what a crystal lattice is like, a highly organized and coordinated arrangement of atoms. And just like an army, this organized structure provides strength and stability. Any disruption to the lattice, any imperfection or impurity, can weaken the crystal and alter its properties. But when the lattice is perfect, when the atoms are arranged in their ideal positions, the crystal can withstand immense forces and endure for eons. This repeating pattern isn't just a static arrangement, it's a dynamic system with atoms constantly vibrating and interacting with each other. But even with this constant motion, the overall structure remains stable and ordered, a testament to the fundamental laws of physics that govern the behavior of matter. But what if matter could find order in another dimension entirely? What if the rules we know, the laws of physics that govern our understanding of the universe, were just a small piece of a much larger puzzle? What if it could repeat, not just in space but in time? We are accustomed to thinking of crystals as static structures, objects that exist in three-dimensional space. But what if we could extend this concept to include the fourth dimension, the dimension of time? What if atoms could arrange themselves in a repeating pattern, not just in space but also in time, creating a structure that is stable and ordered not just in 3 dimensions but in 4? This is the realm of theoretical physics, a world where imagination and mathematics collide to explore the boundaries of what is possible. It's a world where we can ask fundamental questions about the nature of reality, about the relationship between space and time, and about the ultimate fate of the universe. And it's in this realm that the concept of time crystals emerges, a radical and mind-bending idea that challenges our understanding of the very fabric of reality. Imagine a substance that ticks like a clock, forever. A crystal that oscillates spontaneously, without any external energy input, a perpetual motion machine at the atomic level. This is the essence of a time crystal, a revolutionary concept that could redefine our understanding of matter and energy. Unlike ordinary crystals, which are ordered in space, time crystals are ordered in time. Their atoms are arranged in a repeating pattern that cycles through different states, creating a rhythmic pulse that never stops. It's like a tiny self-powered clock, ticking away eternally, driven by the fundamental laws of physics. The implications of this discovery are profound. It challenges our understanding of equilibrium, the state of rest that all systems eventually reach. Time crystals, by their very nature, are never at rest. They are constantly in motion, oscillating between different states, defying the conventional laws of thermodynamics. And while the practical applications of time crystals are still being explored, the potential is enormous. They could revolutionize fields like quantum computing, sensing, and material science, opening up new possibilities that we can only begin to imagine. They represent a new kind of reality, a reality where matter can find order not just in space but in time, forever changing our understanding of the universe. A regular crystal, like a snowflake or a quartz rock, has a pattern that repeats in space. A time crystal does something similar, but its stage is not space. Its stage is time. A time crystal is a phase of matter that spontaneously repeats a pattern in time. But here is the truly astonishing part. They do this in their lowest possible energy state, their ground state. In physics, the ground state is the lowest possible energy level that a system can occupy. It's the ultimate state of rest. Yet a time crystal is in perpetual motion. A time crystal completely shatters this picture. How can something be at its lowest energy level and still be moving forever? This seems to violate everything we know about energy. So how do you build something that sounds like it belongs in a science fiction novel? The recipe for creating a time crystal requires cooling atoms to temperatures just a fraction of a degree above absolute zero. Physicists use ions, which are atoms that have an electrical charge. These ions can be trapped and held in place using powerful, focused laser beams and electromagnetic fields. In 2016, both teams announced their success, publishing their results within months of each other. What they observed was astonishing. The system spontaneously settled into a new rhythm, a new beat. It began to flip its collective spin state only once for every 2 kicks it received. They had heard the first tick of an atomic clockwork that should not exist. In 2021, a team of scientists from Google announced a major breakthrough. They had successfully created a time crystal on Google's Sycamore quantum processor. They could change the number of qubits and modify the driving pulses with just a few lines of code. Consider the exquisite structure of a diamond. Deep within its crystalline heart lies a testament to spatial order. Each carbon atom, a fundamental building block, meticulously arranged in a precise repeating 3-dimensional pattern. This isn't a random jumble. It's a symphony of atomic placement, a testament to the inherent order that governs the natural world. The rigid repeating lattice gives the diamond its incredible hardness and brilliance. Imagine the forces at play, the electromagnetic interactions that dictate this perfect arrangement. It's a static order, a snapshot of equilibrium frozen in time. But what if we could extend this concept of order beyond the spatial realm? What if we could find order not just in where things are but in how they move? This brings us to the fascinating concept of temporal order. Temporal order is the same fundamental idea as spatial order, but instead of being fixed in space, it unfolds over the dimension of time. Think of it as a dance, a choreography of motion. It is an order not of position but of motion, a rhythmic pulse that repeats with unwavering precision. Instead of atoms locked in place, we have a system that oscillates, vibrates, or cycles through a series of states in a predictable manner. This predictable pattern, this repeating sequence of events, is the essence of temporal order. It's the heartbeat of a clock, the swing of a pendulum, the regular flashing of a lighthouse beacon. These are all examples of systems exhibiting temporal order, maintaining a consistent rhythm over time. But what happens when we introduce external influences, when we start to perturb these systems? Can temporal order be maintained, or does it break down into chaos? The answer, as we'll see, is more complex and fascinating than you might imagine. One of the most common and clearest examples of complex temporal behavior is period doubling. Imagine a simple oscillator, a system that naturally vibrates at a certain frequency. Now imagine we start to push this oscillator with an external force, like a laser pulse. We might expect the oscillator to simply vibrate at the same frequency as the laser. But what if instead, something unexpected happens? What if the oscillator starts to vibrate at the frequency of the laser? This is period doubling in action. This means the time crystal only completes one full cycle of its motion for every 2 pushes it receives from the laser. It's as if the system is hesitating, taking twice as long to complete its cycle. This seemingly simple phenomenon has profound implications. It's a gateway to more complex behaviors, a stepping stone on the path to chaos. As we increase the strength of the laser, the system might undergo further period doublings, vibrating at 1/4, 1/8, and so on of the original frequency. This cascade of period doublings is a hallmark of systems on the verge of a dramatic shift in behavior, a transition from order to chaos. Understanding period doubling is crucial to understanding the fundamental principles that govern the behavior of complex systems, from lasers and electronic circuits to biological systems and even the weather. It's a window into the intricate dance between order and chaos, a dance that shapes the world around us. The answer lies in quantum coherence, deeply linked to superposition and entanglement. This collective, unified behavior is quantum coherence. It's the invisible glue that holds the time crystal's rhythm together against all odds. The discovery of time crystals represents a fundamental shift in our understanding of the universe. It tells us that the landscape of possible phases of matter is far richer and more exotic than we ever imagined. They have thrown open a door to a whole new realm of physics, the study of non-equilibrium matter. Beyond their profound implications for fundamental physics, time crystals could be the key to unlocking a new generation of powerful technologies. A qubit encoded within a time crystal could be far more stable and have a much longer coherence time than a standard qubit. We have journeyed to the very edge of what we thought was possible, venturing into a realm where matter itself possesses a pulse, a rhythmic heartbeat echoing through the cosmos. This isn't just about observing static objects. It's about witnessing a dynamic, living universe, constantly in motion and resonating with unseen energies. These discoveries force us to reconsider the very nature of order, challenging our preconceived notions of how the universe functions at its most fundamental level. For centuries we've relied on classical physics to explain the world around us, but these new findings suggest that there's a deeper, more intricate reality waiting to be uncovered. We are on the cusp of a scientific revolution. A paradigm shift that will reshape our understanding of everything from the smallest subatomic particles to the largest cosmic structures. The implications are staggering, potentially leading to breakthroughs in fields like energy, medicine, and materials science. Imagine a world where we can harness the power of these hidden rhythms, creating technologies that were once relegated to the realm of science fiction. This journey into the unknown is not without its challenges. We must develop new tools and techniques to probe these hidden realms, pushing the boundaries of human ingenuity. But the potential rewards are too great to ignore. As we delve deeper into the mysteries of the universe, we are not only expanding our knowledge but also transforming our perspective on our place within the cosmos. We are part of something far grander and more complex than we ever imagined, a universe teeming with possibilities just waiting to be explored. This is a call to all curious minds, to all those who dare to question the status quo and seek out the truth, no matter how strange or unexpected it may be. The universe is beckoning, and it's time to answer its call. It is like waking from a dream, a long slumber filled with familiar landscapes and predictable patterns, only to find that the world is stranger and more magical than you ever thought possible. The veil of the ordinary has been lifted, revealing a reality that is both breathtakingly beautiful and profoundly mysterious. Every corner of the universe seems to hum with a hidden energy, a symphony of vibrations that we are only just beginning to decipher. The laws of physics, once thought to be immutable, now appear to be more like guidelines, subject to the whims of these unseen forces. This awakening is not always comfortable. It challenges our assumptions, forces us to confront the limits of our knowledge, and demands that we embrace the unknown with open minds and courageous hearts. But it is also incredibly exhilarating. To witness the universe in all its glory, to glimpse the intricate dance of particles and energies, is to experience a sense of wonder that transcends the mundane. It is a reminder that we are part of something truly extraordinary, a cosmic tapestry woven from stardust and dreams. And as we continue to explore this new reality, we may find that the greatest discoveries are not just about understanding the universe, but also about understanding ourselves. Our perceptions, our beliefs, and our very consciousness may be shaped by these hidden rhythms in ways we are only beginning to comprehend. So, let us embrace the strangeness, the magic, and the infinite possibilities that lie before us. Let us embark on this journey of discovery with curiosity, humility, and an unwavering commitment to unraveling the mysteries of the cosmos. The universe is waiting to reveal its secrets, and we are ready to listen. The time crystal stands as a shimmering monument, a testament to the idea that the most fantastic possibilities are not confined to our imaginations. They are woven into the very fabric of reality, waiting for a curious mind to come along and discover them. This isn't just a theoretical concept. It's a tangible manifestation of a new state of matter, one that defies our conventional understanding of physics. It challenges the notion that equilibrium is the ultimate state of rest, demonstrating that order and complexity can arise even in the absence of external energy input. The time crystal is a beacon of hope, a symbol of the boundless potential that lies hidden within the universe. It reminds us that the laws of nature are not fixed and immutable, but rather a set of guidelines that can be bent and reshaped by ingenuity and innovation. As we continue to study these remarkable structures, we may unlock new technologies that revolutionize our world, from ultra-precise clocks to quantum computers that can solve problems beyond the reach of classical machines. But the true significance of the time crystal lies not just in its practical applications, but also in its philosophical implications. It forces us to question our assumptions about the nature of time, space, and reality itself. It suggests that the universe is far more dynamic and interconnected than we ever imagined, a vast network of energy and information constantly flowing and evolving. And as we delve deeper into these mysteries, we may find that the answers we seek are not just out there in the cosmos, but also within ourselves. The universe is still full of wonders, waiting to be unveiled by those who dare to dream, to question, and to explore. It is a call to adventure, an invitation to join the cosmic dance and discover the hidden rhythms that shape our reality. The journey is long and challenging, but the rewards are immeasurable. For in the pursuit of knowledge, we not only expand our understanding of the universe, but also enrich our own lives and contribute to the collective progress of humanity. So, let us continue to explore, to discover, and to marvel at the infinite wonders that surround us. The universe is waiting, and it's time to answer its call.